Good morning, sir. I'm Vasanth. I'm doing BE Civil final year in Weltech High Tech Engineering College. The topic I've taken is analysis and design of telecommunication towers. The external guide is Mr. Dr. P.K. Umesha, Chief Scientist in Structural Engineering Research Center, Taramani. And my internal guide is Mr. Mohan M. Tech, in Assistant Professor and is in Weltech High Tech Engineering College. Failures of telecommunication and power transmission towers during cyclones and tornadoes are alarming, even though during design stages these factors have been considered. The recent Thane cyclone, which has hit the coastal regions of Tamil Nadu, especially in Puducherry and Kadalur districts, has suffered many damages. One among them was failure of several lifeline structures such as towers. In the present study, the wind loads are calculated for each panel of the tower by using the IS 875 Part 3 code. After wind load calculations, the load are being applied to the tower and analysis is carried out by the standard software packages and design of members is carried out by IS 800 and 802. In case of any member failure, sections will be changed and once again the wind load is calculated and analysis and design is carried out. This will be repeated for consistent results. Objectives. The objectives of the project is calculation of wind loads and dead loads as per the IS 875 Part 3 code and modeling of structure using standard packages. Design of tower members as per Indian codal divisions of IS 800 and 802. In the recent era, the telecommunication industry plays a vital role in human societies, and much more attention is now being paid to telecommunication towers than in the past. Transmission towers should be assessed about the reliability and safety of these towers to minimize the risk of disruption to power supply that may result in tower failure. Towers are regarded as one of the most difficult form of lattice tower structure to analyze. Uses of a tower. The tower acts as an ideal platform to install different telecommunication accessories that include antenna mounts, platforms, lightning protection kits, safety devices, etc. It is generally used for radars, video surveillance, GSM by CDMA equivalent, wind turbines. Towers. There are three types of telecommunication towers: guide towers, self-supporting towers, and monopoles. These are the images of self and guide towers. Guide towers are almost 150-meter height and are high above, and they are most economical and used widely all around the world. Self-supporting towers are categorized into two. Self-supporting towers are three-legged and four-legged lattice towers. Monopoles are mostly built for heights less than 55 meters and are in triangle also. Monopoles. Monopoles are single circular or polygonal cross-section shafts extending to heights of about 75 meters. Very little land is required to install them, as most foundations require less than 4 meters square of ground space. Failure towers. Many of the towers were failed for wind loads with leg and brace members in angle sections. Few examples are the failure of 101 meter tall microwave tower during November at Kavali, Andhra Pradesh, the collapse of 101 meter microwave tower during November at Ravalapam, Andhra Pradesh. In June 1998, 8 microwave towers of height 80 to 100 meter collapsed during cyclone. This is the model of a tower failure. This is the StatPro model which I have designed. Calculations. Exposed area, that is between the tower and trapezoidal area, what I have calculated. Solid area, actually it is the difference between the exposed area and the trapezoidal area. Now we'll see about the force coefficient, which is taken from the interpolation value. Design wind speed, Vz. Vz is equal to Vb into K1 into K2 into K3, and Vz is 54 meter per second. Wind pressure, Pz is equal to 0.6 into the wind speed square. Pz is equal to the value 1749.6 Newton per meter square, and wind load is calculated. Thus, 4285 Newton is the wind load for the bottom panel. This is for just one panel. There are 20 panels totally in this tower. What is automation? Automation is the process of applying the input data and getting the results in the output. It is an automated sheet of applying only the input in the Excel sheet and getting the result in the next sheet automatically. Here we use this automation for the purpose of applying all the input data in the Excel sheet, and the design and analysis are done in StatPro. Of automation. The Excel sheet contains each panel's joints and members' coordinate details. Next in the Excel, the width and height of each panel is created. Then the exposed area and trapezoidal area is made. By giving the details of about force coefficient and wind pressure, the wind load is automated. Wind load in normal and diagonal is given in the sheet. When this program done in Excel is imported to StatPro, we will get the design and analysis results. This is about the automation in Excel, and this yellow pages are the inputs and the next page will be the output. This is the output data. Wind load calculated, which consists of exposed area, trapezoidal area, solidity, force coefficient, descent speed, and wind load. About the self weight of tower. This is about the self weight in StatPro. This is about the normal load, panel 1. The wind load is 13153 Newton. As taking only the bottom panel, we must consider only the first panel load. And this is 13153 by 2, 6576 Newton. Now for taking for each nodal point, then it would be 6576.4 by 4, which is 1644.2 Newton. Panel 2, normal load. The wind load is for second panel, 14877 Newton. As taking second panel, we must consider the loads of first and second panels, taking half of the load, 13153 by 2 plus 14877 by 2, which will give 14015 Newton. Now for taking each nodal point, it would be 3503.75 Newton. Diagonal load. In the case of diagonal load, the wind load for bottom panel is taken, that is 6576.856 Newton. The value must be multiplied by 1.2. As the wind load is acting diagonally, let us consider in 45 degrees Celsius. So we'll give 6715.349 Newton. As we have 4 nodal points, we'll get 1678.83 Newton. This is about the wind load, normal load in StatPro. This is about the diagonal load in StatPro. Output page which have we got in StatPro. Conclusion. The tower has been analyzed using the Excel containing various types of wind loads and assessed through it. The tower is designed using the StatPro software, which designs the tower with the wind loadings and any deformations is shown. If the member forces are within the allowable forces, the tower formed will be safe.